Thanks for joining me here today. Capable Robot Components is focused on making better building blocks for mobile robots and autonomous systems. We offer products in a number of different areas, including cameras, communication devices, as well as sensors and computing devices. We offer NVIDIA Jetson baseboards, camera interfaces, programmable and instrumented USB hubs, GMSL cameras, and embedded gigabit Ethernet switches. In this presentation, I'll be discussing Cmos Imagers and lenses. For each of these product types, I'll be talking about performance and non-performance criteria of them, looking at vendors and doing a market analysis, and then offering recommendations on how you choose imagers and lenses. Starting off with Cmos Imagers. The first and most important performance criteria for an imager is its resolution, or its horizontal and vertical pixel count. There are lots of different aspect ratios and resolutions out there, and we'll be discussing this in great detail in this presentation. Next is the pixel pitch, which is the distance from pixel to pixel. You also have different shutter types, including global shutter and electronic rolling shutter imagers, and these have different trade-offs in dynamic range and image distortion artifacts if you have the camera moving or objects moving in the scene. The color filter array is also very important in determining your selected imager and varies by your application. If you don't need color information, monochrome imagers make a lot more sense because you have higher dynamic range, higher sensitivity, and you actually have higher resolution because you don't go through a debayering process. There are a lot of different color filter array options. If you do need color information for your environment, the most common is Bayer or RGB, but there are more specialized filters like RCCC, RCCB, and RGB-IR, which we'll not really be getting into in this presentation. Frame rate specifications can be a bit misleading. They often change with operating resolution and the data interface used on the imager, so you have to look at them very carefully. The dynamic range of an imager is the ratio between the full well voltage and the noise floor, and this comes into play when you have dynamic lighting or high contrast in your scene between light and dark areas. Dynamic range of electronic rolling shutter imagers is always greater than that of global shutter imagers. So it's something to analyze and consider, as well as the signal to noise ratio, which is the noise rating of the imager.